KCF Technologies presents Industrial Transformation, Stories of Failure and Success from the Frontlines of American Manufacturing.
Welcome back to the Industrial Transformation Podcast. This is Jeremy Frank, and we are starting a new series of interviews where we'll be looking at the workforce of American manufacturing, and especially where the workforce comes from. And we're starting today at Penn State University with the Dean of Engineering at Penn State, Justin Schwartz. How are you doing today, Justin?
I'm doing great, Jeremy. Thanks for having me today.
Oh, glad to. I'm really looking forward to having a chance to just talk through some really important aspects of what drives the future of engineering, particularly. And I'd like to just dive right in, if that's okay.
Sure, let's go. Engineers are always ready.
Yeah, definitely. Well, maybe I think if you could just tell us a little bit about what brought you to Penn State, how kind of where your career has taken you and why you came here and how you ended up here at Penn State as dean.
Sure. So it's been a bit of a winding road. I grew up just out of Chicago in Evanston, Illinois, which, if you're familiar with universities, is the home of Northwestern University. That's why I was there as a child. My dad was engineering faculty at Northwestern. My mother got her doctorate in special ed at Northwestern and was on faculty at University of Illinois in Chicago. My stepfather was a Penn State PhD alum and psychology professor at Northwestern. So I, of course, having grown up there, immediately went to Illinois as an undergrad in my big state school and majored in nuclear engineering, got my bachelor's degree, spent a couple summers working and holiday periods working at Commonwealth Edison in Chicago. For grad school, went to MIT, did my doctorate there, spent the summer before that actually at Boston Edison in the nuclear industry as well. And then after grad school, went back to Illinois on faculty in nuclear engineering, spent a few years at my alma mater. And then the National Science Foundation moved a major national laboratory from MIT, where I had done my grad work, and rebuilt it basically from scratch at Florida State University. So I moved down there to join that new enterprise to help build a new lab while also being faculty in mechanical engineering. Spent 16 years with the FAMU FSU College of Engineering, and then moved to NC State as the department head for material science and engineering. Spent 8 wonderful years at NC State, and then the opportunity to be dean at Penn State opened up. It's the type of opportunity that if you're in engineering academia, you can't not consider strongly. And so I got nominated. I went through the process and was privileged and honored to be selected as the 12th dean of engineering in the 124 and a half year history of Penn State.
Wow.
Why?
Congratulations.
Thank you.
And also, you've accomplished quite a lot in the time that you've been here, I would say. I don't know that I could rattle off the accomplishments, but I do know in terms of, the research funding that's fueling Penn State's ongoing, the top-notch research, and then just the growth of the programs and the faculty and adapting them to match the needs of manufacturing and industry and other engineering demands is just it's quite a lot. I think I would say from my point of view, having been here for 25 years, there's a lot of really positive activity. So congratulations on both of those fronts.
Thank you. I appreciate it. And I will say we've had, this is my 4th year now. We have had, tremendous support from the university, across the board in many ways. Before I got here, Penn State Engineering went through a period of 10 years where the number of undergraduates in the program grew by like 45%. So the growth in engineering undergraduates at Penn State was bigger than the total number of undergrads in almost every other college at the university. And it's hard. And at the same time, just by happenstance, the university had a voluntary retirement program. So our faculty growth was not nearly as big and robust as our student growth was. But since I started in 2017, so I include the people that started about the same time as me, we've actually added 111 tenure track faculty to our college. So that's like 30% of the faculty have been just in these 3.5 years.
Well,
And so we have in fact, if I look at the median faculty member in terms of experience in the college, it's only about 8 years. So we have rapidly growing, but also a very sort of young and dynamic, forward-looking faculty in our college. And not to say that the ones that have been here longer aren't also dynamic and forward-looking, um, but it just gives a vibe and an energy that you just don't find in most engineering colleges. So just last year, we added over 30 new faculty. Some of them won't come for a year or two because, as you know, when you have the opportunity to recruit somebody great, if you have to wait a little bit for them to start, you do. And even though we're in, there's a lot of uncertainty right now because of COVID and things, we have another 20 tenure line faculty searches going on now as well. So
well,
the university support has been tremendous. And, as you've seen being local, there's construction on campus, and we're looking at a couple new buildings going up to house and support engineering as well. So it's a good time to be here.
yeah, absolutely. You can really just feel the energy. What do so you've been at these other universities and spent significant time at each of them, at three of them, four of them. And some of them are similar in some ways to Penn State. What are you finding that you like about it? Or is it going well for you? Are you enjoying it?
At Penn State, I love it. So there are certainly some similarities. I say that I've been in Landgrant University since I graduated high school. MIT is in fact a land grant, though people don't necessarily realize that.
I didn't know that.
But it's interesting that each university embraces that land grant mindset in different ways, and NC State certainly embraced it significantly. I would say at the time I was at Illinois, they didn't so much, but that was a long time ago, so I wouldn't say now that they don't. And I hear from people that are there that they do more than they used to. But there is nowhere I've been that embraces and talks about the land grant mission and what it means to us today more than we do here. So land grant history is, it was the transformation of U.S. universities from being, really just focused on the elite and sort of the Ivy League mentality, whether it was Ivy League or not, to really being a robust system for education and advancement of the entire population. So land grant started really with three missions: agriculture, engineering, and defense. It was called military science back then. But really with this aim of accessibility and affordability for everybody. And so, our undergraduate population is still over 30% first in family to go to college. And we talk about issues of affordability and access of our students. It's one of the number one themes that we talk about regularly in terms of how we advance the university. And so the land grant universities tend to be larger, and they tend to have really strong engineering. So, it's not coincidence that that's what I focused on as I've moved from place to place. The thing that I think makes Penn State stand out significantly from the other places I've been, however, is our ability to work across disciplinary boundaries within themes, topical themes. So the University of California, Riverside did an assessment about a year or two ago, I think it was, where they were looking at these things. Universities do these things called cluster hires, where the university makes a decision: we're going to hire, 8 faculty in sensors, but they're not necessarily going to be in any one department. They're going to be, the 8 best people we can find that fit together to build a team focused on sensors, and they'll be in whatever department makes sense. So UC Riverside was thinking of doing a cluster hire, I think, and so they decided to assess what happened across the country with cluster hires going back to the early 90s when the idea really started, I think, at Wisconsin first. And they actually came to an interesting conclusion. They came to the conclusion that cluster hiring across the United States had failed everywhere in every single example, except for one exception, and that one exception was Penn State. And it's because Penn State has really built into its mindset and culture this interdisciplinary idea of working together. We are not built on siloed organizations. We are built on people who recognize the value of working in teams, who recognize the value in peers and colleagues across the university. And then we baked that into the system with our institutes. So we have the Materials Research Institute, Hug Institutes for Life Science, Institutes for Energy and Environment, Institute for Computational Data Science. I'm going to feel bad for the ones I forget to mention. There's a few others: Penn State Cancer Research Institute, Rock Ethics Institute, and Social Science Research Institute. Don't want to forget them. And what this has done is, while those institutes are focused on the research side, it creates this environment of interdisciplinary collaboration across, that broaches into the academics also. So one of these two buildings that we're building now to bring this home to engineering is the one that's actually already has broken ground and will be the first new building for engineering to open up in about 2 years, is focused on undergraduate education for all engineering disciplines, with the idea being, let's bring all of our students together that are in engineering, regardless of major, and have infrastructure to support them to work together, in whatever it is they're doing. So our first year engineering program includes a course like eDesign 100. It brings all of our students together. There's also the freshman seminar, and this brings students together so that we have students who are anticipating being in engineering, science, and mechanics, working with mechanical engineering, working with electrical engineering, and doing things together with that mindset of partnership. And then the same facility will house our learning factory, which is our capstone design facility. Right now, it's in an older building that's right near where the new one's going up, but it's going to grow in physical size by about a factor of 5, from roughly 6,000 square feet to about 30,000 square feet. We call it a makerspace, but it doesn't fully describe what we envision. We're talking about a design platform space, maker space, prototype space, manufacturing space. So we're also going to bring our manufacturing education facility into that building.
No, you said 5 times bigger, 30,000 feet. I mean, 30,000 square feet. Wow.
Yeah, 5 times bigger than Learning Factory, with expanded mission, right?
Yeah.
But the idea
I know it well. That's a place where I think, we've actually donated technology and work actively with the groups. And I mean, back to when I was in undergrad and grad school, I spent a lot of time cutting parts on the milling machines in the Learning Factory. So if increasing the capacity of that by 5 times, that is a significant investment in capability. Wow.
Yes, and that's the goal. We looked at what Learning Factory could do, and it's great, but I think, in my vision, we need to transform it from being, a sort of production facility, which is valuable, right, to, I want a student to be able to walk into that building at any point in their career, whether it's part of a class or just something they thought of when they're at the gym. Sit down, take their idea, do the computer design work, right, and then be able to go to 3D print, and then go to prototype, and have the ability to include not just the physical construction, but anything on the electronic side and the coding side, and then even have that vision of how it links to manufacturing by having the FAME lab will move there also, right there on the floor in that one facility. And as they're sitting there working on their project, on their idea, they won't have all the disciplinary knowledge they need, right? But there'll be other students around who might. And so create this opportunity to move their ideations forward in a real way, so they get that experience of self-motivation and looking for the expertise they need to do what it is they need to do. I was talking to an alum about this who graduated Penn State engineering back in 1967, had a fantastic career in industry, spent some of his career at GE during GE's heyday. And when I described this to him, he just looked at me like, yeah, that's how we do it in industry. Like, I mean, it was sort of matter of fact, of course, that's how things should be. But it's actually kind of new to academia to think about keeping our students together as much as possible, even while they're getting their discipline-centric classroom experiences, that follow the curricula, that match ABET so they can get their accredited degree, keeping the environment rich for this kind of interaction an opportunity space is just not commonly done in academia. And that's what we're looking to do. We're looking to make sure our students have my job as Dean of Engineering, one of my jobs is to make sure that every student I graduate is more ready for whatever it is he or she wants to do next than anybody else, right? We've got over 8,000 undergraduates in the program. They all have different ideas of what to do next. I need them all to be ready to do what it is they want to do next. And to me, this is a central piece of it. Even though we're doing a lot of remote learning now and hybrid learning, we're learning a lot about how to do things through remote tools effectively. But I don't think we're finding that we can just get rid of hands-on education.
Sure.
I think in the long run, learning to better utilize remote tools just enables us to do a better job also of hands-on, right? By virtue of freeing up space and resources to commit more to the hands-on part. And that's what we're looking to do with this new facility. And with it, we'll be doing an assessment of, our undergraduate curriculum in that intersecting space as well. So we've got the time it takes to build the building to also, re-energize and rethink about the way we do our programs. How do we have some students who are in industrial and manufacturing engineering, and they really want to focus on manufacturing. Fantastic. I have a lot of other students who don't want to have don't think of their career as being manufacturing, but they want and need exposure to manufacturing and understanding of it because, design without understanding manufacturing can have some real pitfalls, right? You've got to be able to make what you design. And so trying to find ways to just give that broader exposure across the disciplines and across the spectrum of engineering activity is really what we're trying to accomplish.
That's great. Let me pull it back, Justin, because one of the things we talked about when we checked in last week is just, both for our hiring. I mean, we've been hiring a lot of people, especially out of Penn State engineering, but, just across the board. But especially the customers we serve, industrial companies, manufacturing companies. It's so clear that that's what they need. They need smart students with kind of cross-functional, diverse experiences who can work with other people. I don't think too many people would challenge me on that. The thing you said that I thought was really interesting is that from the student point of view, first of all, that number that only, that maybe between the foreign students and the 30%, first in their family to college, roughly half of the students are the first person realistically, getting a college degree in America. And they just want a job, but they don't just want a job. They want to do something important and make the world a better place. Can you speak to, what you do to try to enable that?
Sure. So, that process for us really begins with messaging to students who aren't students at Penn State yet, high schoolers, right? And even younger. What we see in this generation of students is, like you said, the goal of having impact. So I was sitting around my first year as dean at a table, a 10-seat table, 9 high school seniors and me. And they were all, in classic form, looking at their phones and typing, and nobody was actually talking to each other. So I said, hey, let's have a quick conversation. I said, I'm just curious. When did you decide that you want to do engineering and why? And literally one after the other, the when was actually interesting. It was only in their last couple of years of high school, which tells me that as long as we keep students that are younger than high school engaged in mathematics, so they're preparing themselves, we have that window in high school to reach them. And they only gave they said it different ways, but they only gave 2 answers for why they chose engineering. About half of them said, my dad's an engineer, my mom's an engineer, my grandfather's an engineer, my sister's an engineer, my brother's an engineer. It was the family business, right? The other half, to a person, talked about having impact. So none of them said, I like to tinker with my car and I want to learn how cars work, right? Which is sort of my generation mindset. None of it was, I want to build a faster this or a stronger that. They all said, one girl looked up from her phone, looked me in the eye, said, I want to improve the world. And so, of course, I chose engineering. And then she went right back to her phone. It was sort of a matter-of-fact mindset that that told me that when students understand what engineering is, right, that it's taking human knowledge and applying it to bettering human life and society, they want to be engineers. It's that simple. This generation is really focused on that impact piece. And so
It's
as we,
interesting that they make that connection though too, because I wouldn't necessarily assume that a high school student would would make that connection naturally. You know, you might think that you have to run for political office or something, whereas
right.
I think you and I both know it's extremely true
Yep.
that engineering is probably either the or a one of the most impactful roles in society you can provide, especially just like
Right.
the manufacturing side of it. I mean, the needs are just so strong and going to get stronger
That's right.
as the workforce challenges really become more significant.
Right.
So that's great to hear, actually.
Yeah. And so what we've done is we've taken it upon ourselves to try to make sure that message gets out. Right. It's actually, to me, from a point of view of trying to recruit good students into engineering, it actually was refreshing, not just to know that, the children who are going to, the high school kids who are going to grow up and take care of me when I'm retired are focused on impacting the world, not just on themselves. But it also told me that as a dean of engineering that's trying to recruit more students, into the discipline, that if all I have to do is explain to them that they're going to have impact, they're going to be interested. That's a lot easier, right? That's an easy message to convey. So we built out, and I think you've seen these, a suite of videos. We have a 5-minute video for every single engineering major in our college, where the presentation is the impact that major can have on the world, right? So, it's hosted by one of our faculty, but it's got current students talking. It's got alums talking about what they're doing in their jobs, how their job is letting them have impact. And every department has one, and the energy and pride and the discipline comes out, but the impact of the discipline is just a resonant message that comes across over and over again. So we're hoping those videos will do two things. One, get more and more students interested in engineering, and of course we hope they come to Penn State, but we need more engineers across this country, not just, and Penn State can only produce so many of them. And then, but also we hope that helps them, make the right choice in terms of which engineering discipline to go into, because that's something we worry about, in that, students coming out of high school, there's different levels of familiarity with the different degree paths, and making sure they choose the one that really makes the most sense for them, rather than the one that they just heard more about, is really important also to student success. Because another thing we focus on a lot is student success. We want our students to join our program, thrive in our program, and graduate and get to you. And part of that is then making sure that they make the right choices early, right? So that they don't get a couple of years in and say, wow, I don't know why I'm doing this EE, I'd rather be an ME, or why am I doing ME, I'd rather be doing BME, right? And so we want our students to really understand, the whole 360 view of the engineering world.
Yeah, those, just for the listeners, we'll definitely post some of the videos that Justin is describing. They really are fantastic. I'm a little biased to the mechanical engineering one, just because that's the program I came from, and it's really quite excellent. It absolutely describes what you said. I mean, you watch it and you just feel inspired, because there's so many ways to make a difference. It's also, I'll just give a shout out to when I rewatched that video last week, I was reminded that Kelly Karski, formerly Kelly Lentz, she was actually an intern at KCF while she was in school, and worked on some of these hands-on learning factory projects, but then also worked at our company while she was in school, and she ended up going to work in the as an engineer serving the power industry. But it just gives a great example of what a person is focused on while they're in school, but then what they accomplish 5 years later. I'm curious to ask that. How do you, so you're the dean and you're looking at how to have the best match between the students' desires and having them prepared for what they most want to do. How do you measure that? Do you have, what do you consider the best way to measure that successful preparation and fit?
Oh, that's tough. I mean, to a certain extent, you look at how often do students try to change majors late, and we don't have a lot of that. But part of that is the practical side. Students who want to go into engineering will realize that even if they as long as they do well, if they graduate in, the major that may not have been the optimum for them, getting into something else isn't that hard within engineering if you have an engineering degree, right? And I mean, I'm a living example, right? So I have bachelor's and PhD in nuclear engineering, spent 3.5 years nuclear engineering faculty, 16 years mechanical engineering faculty, 8 years material science department head, and at Penn State, my home department is engineering science and mechanics. And my work has gone from, ceramic materials processing of superconductors to their magnetic behavior. Now most of my work is focusing on real-time distributed sensors with optical fibers, in cryogenic systems. So, in engineering, and this is the other point we make to potential engineering students, is if you get a bachelor's degree in engineering, you have really not closed many doors in terms of your future. Sure, if you wanted to be a concert violinist, maybe it took you away from that. But I'll have students, I'll talk to high school kids and they're like, yeah, I can't decide whether I want to go into business, get a business degree or an engineering degree. And I say to them, well, if you get your business degree, I'm sure you won't become an engineer. If you get your engineering degree, you could very well become a CEO of a business. So so that should answer your question, which one to go into, right?
Sure.
Because engineers go into leading roles in business and industry. They go into leading roles in the military. They go into med school. They go to law school, right? They become accountants. They do that while doing engineering also in some cases. It is truly one of the most flexible degree platforms one can launch from.
No doubt. It's funny. I'm reflecting. In some way, I would have not measured well against your criteria. I actually considered changing my major, or at least changing my discipline right towards the end of when I was doing mechanical engineering at Penn State. I thought about shifting my course focus and applying to medical school as late as my senior year. And I talked to a career advisor who promptly told me that was a really lousy idea, based on what we talked about. And I kind of realized that they were right. Although then subsequently, I never even got or even applied for a full-time job. I went into grad school and still didn't apply for a full-time job. But nonetheless, I ended up as a CEO. So I think as long as you have a long enough view, you can measure success how you like.
That's right. Well, I'll often joke with the students and tell them, if I can't tell them what they're going to do with their career, but I can pretty surely tell them the one thing they won't do with their career. And that's whatever it is they currently think they're going to do with their career.
I like the way you said that. Yeah. Yeah. Because people, I go and I speak at classes, a few times every semester. And that is a question that recurs, is that the students want advice on what they should do next. And I have a really hard time not saying just don't worry about it. It doesn't really matter.
Right.
Like thinking about it doesn't, well, it's actually thinking about it is good, but worrying about it is what I try to suggest is just a waste of time, because there's so many different possibilities. It's like a flag waving, flying through the air.
I always tell them, whatever they do, try to choose paths that don't close too many other doors. Right. And so, if they're really torn between, path one and path two, if path one really is potentially a dead end and takes you down a road that doesn't leave you flexibility for what comes next and after that, but path two does, that may be a differentiating factor for thinking about what to do, right? Keep your options open, as your career develops, add to your skill set, add to your experience base, and remember that, you'll move from A to B at times, but always leave on as good a terms as you came in, and don't disregard the importance of relationships.
Yeah, and keep your options open for sure. That's good advice. Justin, I want to shift gears for just a second. I wanted to, when we talked a little bit about on the industrial side. So, where the students are going, a lot of them is into industry, and you have the Industrial Professional Advisory Committee, I believe it's called.
Correct. Yep. Yes.
Can you just describe a little bit about why that exists and who participates and what the purpose is?
Sure. So we have, IPAC is big. We have 13 departments in the college. 12 of them have their own IPAC, and the 13th is actually starting to build it out. And the idea is that each department has this group of, say, 10, 12, um, mostly industrial leaders. There's a couple from academia, a couple from labs, depending on the specific department. Um, Many of them are alums, but not all. And the idea is, we live in academia, but we are serving so many different aspects of society that we need strong advisory input from industry, mostly industry, to help us make sure that we are, fulfilling our role in this bigger societal ecosystem, right? And so, historically, the way we've functioned is everybody, the whole team, so it's about 140 people across all of the departments, come to campus for a couple days, right? They start out getting a college overview from me, updates on all the different things that are happening, and then usually the college poses a couple of topics for them to talk about, and then they break up and go to their individual departments where they'll talk about the things that maybe the college put forward, in the context of that department, and then also get updates on what that department is doing and give the department feedback on different things they're working on. Um, they serve a role in our ABET review. We're supposed to get uh, industry survey feedback on our curricula and how those are doing. So they serve that role also. But it gives us a chance to get input from some really really smart people in the field about is our undergraduate program serving today's need but also tomorrow's need? Are our
Mm.
graduate programs serving today's need and tomorrow's need? Are we thinking about the right research topics to partner with industry? So that's been going. We've been doing that every year, and then the iPad. Each group, gets together without us and puts together their thoughts and their feedback, and they present it to the departments, and they present it all to me, and they make recommendations that we try to. We really do take to heart and implement, and it helps steer our thinking. I know the department heads think it's a great way to get me, the dean, to give them what they need. But it's also a great tool for me to understand, the bigger picture and to work with the university to help make sure that the college is remaining at the forefront.
And
This
what would you say you've learned, recently, or especially what are the gaps? Like, what are the biggest gaps between what you're hearing that they need and what is currently happening at Penn State?
So, one of the things that of course wasn't a surprise is the propagation of the need for more and more understanding of computation across disciplines.
Mm.
We knew that, but it was we live in our bubble. We thought that was the case, but often what we get is confirmation as well as new insight. The other thing that we've gotten from various sectors, which we're happy to really work and engage with, um, is this issue of the leaky pipeline and diversity and equity inclusion issues. So some of the larger employers would come to me and say, hey, we hire 50 engineers one year, and 5 years later or 10 years later, you know all 25 men that we hired are pretty much still with us, and most of the women have left us. What We need your help. What can we do? Right? And similar stories for hiring African American or Latinx. Right? This leaky pipeline. And at first my thought was, well, I don't know how I can help you at your site in your culture. Um, but the more I thought about it, we graduate at Penn State over 2,000 engineers a year. So that means over the next decade, I'll graduate over 20,000 engineers who, whether they go to grad school first or not, are mostly going out there into the workforce, right? They're engineers in your company, companies like yours, companies like GM, defense labs, Lockheed Martin, all over the place. And my job is to make them the most desired student that's graduating when they graduate. And it occurred to me that it's become so clear to our industry friends now that the culture at their workplace is so important for talent retention, and that's amplified when they are focusing on retaining female talent, retaining underrepresented group talent from the different groups. but that culture isn't, isn't dependent upon just how many women they hire and how many Black engineers they hire and how many Latinx engineers they hire. It's really dependent on the behavior and culture of, you know, the white males that they hire, right? And the white females in terms of racial demographic issues. And so, it occurred to me that part of our job is making sure that all of our engineers are going to graduate and be a positive contribution to their work culture, no matter what their demographic is, right? Whether they're first in family from the farm or, fourth in family to college from a big city, regardless of race, regardless of gender, everyone needs to come out with this understanding and appreciation of the value of a diverse group, right? So just as we recognize easily that a group that has different engineering disciplines together, an EE working with an ME, working with a manufacturing engineer, working with a biomedical engineer to develop a great bio device, needs that intellectual diversity. Understanding the importance of diversity along demographic axes is also just as important to their success. So we are now looking at, these issues related to equity, not only as a mission of how do we support all of our students so that, the smaller population students can feel welcome and graduate, but how do we actually help all of our students understand the importance of professionalism, which is really to me what it is, uh, professionalism in their careers. And so this is something that we were talking about and thinking about, but our interactions with IPAC also very much helped us frame it in this context of not only a social justice perspective, but also a professional obligation. It's my obligation to train all of my students, right, to be the type of person you want to hire and that will help your company thrive. And if they're a great engineer technically and their behavior causes you to lose 3 people a year, that's not necessarily a winning proposition for you, right? And so looking at it from that perspective, that industry perspective, I think helped us think through, this bigger picture aspect of how do we train an engineer to be a success in the 21st century workplace.
It's really interesting, Justin, and just this topic of equity and inclusion is just such an important one, and it's I don't know if I'm biased or not, but I feel like that's something that Penn State generally has a really strong reputation for already, but
Mhm.
it's never good enough. I mean, just
Right.
to really make that a strong effort. I know I appreciate that as a company hiring lots of engineers from Penn State. It's so important. I mean, just
Mhm.
creating that culture. If you're starting with people who are already trained for just professionalism and respect, it's everybody. It's one of those things that just benefits everyone.
Right. We need
Are
to,
you able to measure any impact, or do you have any stories of what's going on, or how the effort's going in that regard?
we're getting there. So we are, we've been ramping this discussion and dialogue up over the last couple of years, and our current conversation right now is, I mentioned before in the with respect to the new building and being post ABET, looking at our first year curriculum, we're looking at how do we embed this into design. How do you teach engineering while also teaching the importance of diverse thought and equity, right? So you know how do you get someone to think about you're designing something, you're not just designing it for a 6 foot 195 pound man, you might be designing it for a 5'2" pregnant female, right? And infusing the human piece into the design space, I think, is really important for creating um, the more valuable, more impactful engineers. So we're talking about how we do this in our curriculum, through in the first year experience, but throughout. I was actually on a Zoom meeting this week with what we call the Big Ten Plus deans. So it's all the Big Ten engineering deans plus a handful of others from other universities that we invite, even though they're not Big Ten. And I brought this whole topic up of how do we infuse this into our undergraduate program. And our plan is to think about how we as a group of deans can communicate with the American Society of Engineering Education and try to get this to be a professional community initiative, not just a series of universities trying to do this. And we're talking about how do we go to ABET and have them think about including under the engineering ethics rubric, the issue of how are we all teaching engineering equity? Because I want Penn State to stand out. I want us to be the leaders in everything we do. But on a topic like equity, I'd rather us be leaders in transforming the profession than simply leaders in the academic space, right? So we're going to do this, and we're going to infuse this in our curriculum, and our engineers are going to be ready to give you a positive culture on day one. But frankly, I'd be happier if every engineer in the United States graduated with that. I don't want to be the only engineering school that's teaching thermodynamics, right? That would make no sense. And so, also keeping in mind, right, selfishly, we're going to recruit students from other schools into our graduate programs. I'd like them, just like you want them to be ready to be good, cultural citizens on day one, so do I. We're going to hire faculty from all different universities across the country. I want faculty who understand this concept. So, to me, this is somewhere where we're going to be amongst a handful of universities that are leaders, but ultimately we hope that everybody catches up.
Yeah, that's a great aspiration. I so appreciate that, again, both as a company, but just as a citizen. We actually are running up against our time, Justin, if you can believe that. But
wow.
It's been a fascinating conversation, but I have a couple questions that actually this flows really nicely into.
Sure.
Because, it's interesting. We've talked about a lot of really positive things, but the question of equity and inclusion and race issues particularly has been such a challenging one this year. But really, I want you to take this wherever you would. I'm just curious, from your role and what you've been doing the last 3-4 years and what you see ahead, what is the biggest challenge that faces us that isn't solved yet, that you really want to work on and you wish you could just sort of snap your fingers and solve?
You mean in human society, or you mean in academia?
I guess I mostly mean in the context of Penn State engineering,
Right.
But really take it as you will.
Sure. So, in the context of Penn State engineering, the challenge is, we have some big challenges in society, and I kind of look at the balance of my department's focus on excellence within their department, and my focus is on these interfaces between engineering and other disciplines, right? So how do we in Penn State engineering make sure that, we are becoming a leadership voice in solving humanity's problems, right? And engineering always has been, a leading player in solving humanity's problems. But I think historically we were sort of a societal toolkit, right? A problem comes up, you go to the toolkit of engineering, you pick out the one you need and you fix the problem, then you put us back in. I think we have become so technical as a society, as a species, that engineers need to not just be, standing by and ready to help, but really taking more of a leadership role in saying, this is a problem and this is how we solve it. I think you've seen that happen sort of naturally with COVID. You look across the country and how many universities have these big efforts to scale up manufacturing of PPE and other needs of hospitals, scale up, and already, industrial engineers looking at how will we do mass production of a vaccine when it's ready? How do we scale up distribution, which is really as much an engineering issue as a human issue? So I think engineering needs to think about how to change its own role and assume a mantle of leadership that it hasn't necessarily done before. Even before COVID, I would comment to, people in the life sciences here at Penn State and say, look, I know that this may not be a popular opinion, but in my view, in the next 20 years, there will be more medical advances and breakthroughs coming out of engineering than out of the more traditional biological sciences. And not in the absence of the biological sciences, but because engineering is now incorporating biological sciences to such a great extent as one of our core scientific underpinnings. And we are so focused on impacting the world, and the interface of humans and technology is growing so rapidly. We see it in autonomy space, but we also see it in the medical space. And so, the solutions for climate change are known. Many of them are engineering, but some of them are not. But this concept of implementation is something that's important to us. So seeing, to me, the big challenge is, engineering taking a leadership seat at the table when it needs to, and continuing to be seen as a partner when that's appropriate. So, at Penn State, we just launched a couple of years ago a big initiative to combat addiction. And when the program was first being formulated, engineering wasn't really involved. But then as it emerged, our role became clear. And so now we are very much participating in that. It's housed where it should be in the Social Science Research Institute. But engineering has an important role in solving a problem that, the person who's out there that's not technical, that's not looking at universities, may not have immediately thought that, oh yeah, we need engineers involved in fighting addiction, but we do. And so having that mindset permeate engineering, and then society recognizing it, is, to me, important. I mean, I joke all the time. Imagine if the government in DC, the Senate and House, was full of engineers rather than lawyers. How would we be doing? Right? And I have friends who are lawyers, so I mean, I'm saying that with respect for lawyers, but engineers are trained to solve problems, and that problem-solving mindset is so important in today's world.
It's true. It is. I mean, it's funny to think about that. It really would be marvelous. I have to think,
Mm-hmm.
that it might not be as social, but it would be far more productive.
Yeah, exactly. Well,
less yelling and more problem solving. But so I'm curious. I just completely agree with what you just described. I mean, our whole company, our focus is just that exact convergence. There's no real shortage of technology. There's so much at our fingertips. It's just a matter of putting people in a position where they can use that technology to solve problems, and that's what engineering, especially mechanical, is. And I think there's a diversity of outcomes. If you look out like 10 or 20 years, there's some people that would say the Earth is going to be a big, dirty fireball, and everyone's going to be dead or nearly dead, and the, species will all be degraded. And there's other people that I think look at it and say we can solve all these problems, and it'll be unicorns and butterflies and blue sunny days. I'm curious what you think. How do you, from your vantage point, seeing all these students come through a place like Penn State, are you feeling positive about where we're going to be in 10 or 20 years?
Absolutely. I'm an optimist in general. I grew up a Cubs fan, so you had to be. But I think about, you probably don't expect to hear me quoting Faulkner, but in Faulkner's acceptance speech, I think it was for the Nobel, he talked to, I think he said, I learned this in middle school, and I can almost do it verbatim since. I probably mess it up a little bit. But he basically said, I do not believe in the end of man. Man is immortal. He will prevail. He is immortal. Now I'm blowing the quote. I thought I could do it. But that was Faulkner's message, was that humankind, and he said this in a time when people were worried about the existential threat of nuclear weapons, which we still have. But we don't worry about it like we did back in his day. But the concept was, I don't accept that humanity is going to end because, humanity's ability to solve its problems, exceeds its ability to create them. What I find interesting, the reason this quote comes back to mind to me often, is that, in Faulkner's mind, the way he described it, I wish I could remember the poet, the words more precisely, was that it was going to be, the poet, the writer, the social scientist, and the social voice that motivated humanity to overcome its problems and survive. Whereas today, I think it's the combination of our technical genius working with our social genius, right? And that's why I get so excited and so optimistic about having all these engineering students who just want to improve the world. That's what gives me the optimism. It's not that I have just great engineering students, and it's not just that kids these days want to make the world better. It's that engineering students want to make the world better, and that is to me what what gives me the belief that we are going to overcome our hurdles and solve our problems. Albeit with some pain along the way, as we've already really seen. Right, if you've watched California burn this year. You know that these solutions aren't going to come without pain in the process.
Absolutely. Yeah, but it does. I agree with your optimism. I just think the problems are solvable and we're on that path. But yeah, we need equity, we need inclusion, we need smart engineers solving problems, and we need that professionalism too. It's a multifaceted thing. I have one last question, and then we do need to wrap up before we run out of time. Last question is just one I really like to ask people, and I'm curious to hear how you'll answer it. It's a question of just divergent thought. And the question is, can you tell me something that you believe to be true, that you know to be true, that most people would disagree with you about?
Boy, that's a tricky one. That I believe to be true that most people would disagree with me about. Well, I don't know if I would say most. So there's if I can answer that within the context of sort of academia, then I can answer that. But most people that are listening may not have heard had an opinion one way or the other. So there is a lot of talk in the academic world that we're sort of approaching a cliff in terms of decreasing interest in higher ed across the United States. That because we are graduating less students in high school, that we're going to have this shortage of students coming into higher ed, and that a lot of universities are going to really struggle with enrollment, and places like Penn State will do great, but others will go under. And I think, and I heard that story, and I disagree with it. Most people buy it as sort of dogma. I heard that similar story like 20, 30 years ago. And it goes down to looking at the details of the model. So what's really happening is the demographics of high school graduates is changing because we have a growing Hispanic population and a not fast growing white population. And if you assume, and in general in the United States, whites go to college at a higher rate than Hispanic or Latinx or Black. However, if you just focus, say, on the Latinx right now, that like every other immigrant group in the last 100 plus years in the United States, that, as you get into second and third generation, the rate of going to college goes up, right? Then you actually will see that what's going to change is the demographic of the college student, not necessarily a plummeting of the numbers. And so, so when I think about it, I ask myself, and this isn't a problem for next year, because right now the numbers are, it's one of those things where the forecasts are all, for the next few years, it'll keep going up and then it's going to drop. But that few years seems to shift. How are we thinking about, the next generation of students, or maybe next half generation that are coming through our K-12 system? How are we making sure that we're preparing, and this goes back to the equity and inclusion topic, but it takes it into a younger domain, but it also takes it beyond STEM and into the broader population. How do we ensure that we're instilling the value of higher ed in all of our K-12 populations, and ensuring that when they get through high school, the system is there for them to have affordability and access, right? So rather than having this panic of, oh no, there's not going to be enough students, why don't we think about how do we really take advantage of the students that are coming through our K-12 system and prepare them to really, in the same way we have previous generations.
I like that. I mean, it sounds like you're looking at it like an engineer solving a problem as a system, which I think is a pretty good way to look at it.
Yes, the world is a big system.
It is. It seems perfectly rational to me.
Yeah.
Justin, I need to wrap us up there. And I've really just absolutely enjoyed this conversation with you.
Me too. Thanks for having me.
Thank you.
Can I put one plug in, Jeremy?
Oh yeah, please.
So we talked here and there about during this past hour about Learning Factory. I want everybody out there to know that our Learning Factory is always looking for more industry partners to come and have a team of 3 or 4 senior engineering undergraduates working with you on a project that you define. I know, Jeremy, you've done a bunch of them. You don't have to be in State College. We have companies all across the country that work with us, and you will not regret it if you join.
I will absolutely endorse that as well. We've done probably a dozen of those types of projects, and it's fun, rewarding, and you get a positive outcome. And it's a great way to recruit and get to know the students as well. So yeah, absolutely. I heartily endorse that.
Great.
Yeah, it's been quite a pleasure. And I thank you very much, Justin Schwartz, Dean of Engineering at Penn State University. And this is the Workforce Focus Group Topics in Industrial Transformation.
Thanks.
Thanks, Justin. Appreciate it.
Thanks for listening to the Industrial Transformation Podcast, a production of Business Builders Media. Learn more about how KCF can help you on your industrial transformation journey at kcftech.com and check out more shows on businessbuildersmedia.com.